Hi guys, it's Andy McDonald, physio and strength and conditioning coach, and welcome to the Informed Performance podcast. On today's show, I have the pleasure of speaking to JB Morin. JB is currently a professor and the head of sports science and physical education at the University of Saint-Etienne in France. Outside of academia, JB is a highly sought after and experienced consultant and track and field coach who also supports the efforts of athletes and teams in professional sports. JB's field of interest and expertise is mainly around biomechanics and performance, with an interest in running and jumping biomechanics. In this episode with JB, we will be discussing GPS usage, resisted sprinting, and profiling athletes. This episode has been sponsored by Vol Performance, makers of ForceDecks, the world's fastest, easiest, and most powerful dual force plate system. ForceDecks can help you to analyse neuromuscular strength, performance, and imbalances in your athletes. With an incredibly simple setup and intuitive software, ForceDecks automatically detects over 15 common force plate tests and analyses them with a single click, helping you to collect quick and accurate insights on your athletes. To learn more, head over to our sponsor, volperformance.com. You're listening to the Informed Performance podcast with me, Andy McDonald, and here is today's episode with JB Morin. JB, firstly, thanks for coming on the show, mate. Just to kick us off, we've got a fairly mixed listener base in terms of the professions that they belong to in sport. So there may be some people tuning in where this could be their first encounter of you. Would you be able to just kind of, introduce yourself and tell us a little bit about your background?
Yeah, sure. Thanks for having me first. Real pleasure to speak here. I'm currently a full professor of sports biomechanics and performance at the University of Saint-Etienne in France. My background is a PhD in locomotion biomechanics back in 2004. I have also a coaching and track and field background as an athlete, and I'm also coaching and consulting for some elite sports where sprinting is involved. So track and field, basketball, football, soccer, and so on. So that's my activity.
Cool. And, I know you've done a lot of academic research and, without making you list every individual paper, would you be able to give us some kind of context as to, the main areas that you're interested in, broadly speaking?
Yeah, sure. So my main area of interest is overall locomotion biomechanics at first, then running biomechanics, running performance, and especially sprint running biomechanics and performance. And the recent years have been towards first connecting that to hamstring injuries, because definitely running mechanics has to do with hamstring injuries. And also connecting that to field performance methods. So over the years, I think the first one was published in 2004. We've always tried to provide people who are not able to have and use laboratory devices some simple methods to calculate and compute some very key variables. So we call that field methods. So thanks to the use of field methods, we can also apply our more laboratory-based research.
Cool. And I know before we got on the call, you were mentioning, three big areas of GPS-resisted sprints. Would you be able to kind of talk through, what, I guess, with GPS first, what you've been mostly looking at recently?
Yeah, so we've looked at with the improvement in GPS signal and data quality. We've looked at how to use GPS units not only to assess, I would say, volume, running distance, running times, et cetera, but very high speed and very high power events, so accelerations. And so we wanted to see how GPS can be a speed measurement tool during maximum speed trials, so single linear sprints. And we call that in situ speed profiling during team sport. That is the accelerations and speed events. So trying to profile the players based on only the use of GPS units, because I think it's simpler and some recent models are accurate enough to do that instead of using different technologies such as a radar, a laser, or I don't know, timing gates that might be a bit more expensive and a bit less practical to use. So this is what we are now investigating.
And I mean, I don't know whether you can comment on this at this stage, but how accurate are you finding GPS for detecting high speeds?
Yeah, so I think it's been almost 5 to 10 years that the most accurate GPS are okay to measure very well speed plateau, which is very high speed but constant speed. The question was, and the accuracy was much lower on acceleration events when the speed changes very rapidly. But the very last models we've used and tested compare correctly to linear encoders and to laser or radar devices. They don't match perfectly due to differences in data processing and data analysis between the different systems, but they show the very same inter-trial differences. So it means if you want to do some intra-athlete comparisons or some group comparisons, and you use always the same device, GPS, then for maximum acceleration to maximum speed, the last units we've used from Catapult and GPXA, they are really okay. Or, of course, as always, if the measurement conditions are okay.
And correct me if I'm wrong, but there must be some kind of in-field sporting advantages as well to GPS. If you were looking at, say, I don't know, like a high jumper or maybe a baseball player, it must be easier to get a more accurate sort of and specific speed profile for them in their environment than maybe you could set up with gates.
Yeah, absolutely. This is why, to me, it's very interesting because, of course, so the big advantage of GPS is that, and the big disadvantage is that you have to be outdoors in a very open field and blah, blah, blah. So in some stadiums, you won't have a good signal. But if you have a good signal, then you can measure practically anything in any sport. And some of our current research is assessing track and field people with in-race, even at world elite events, in-race measurements, for example, during the 110 meters hurdles, or warm-up pacing and strategies. So it's definitely bringing much more information about the movement and the performance, yes, for sure. It was limited to a few team sports in the past, but now it's really anytime there's open field and open sky measurements possible. It's really interesting. To give you an anecdote, I very often work with athletes myself for coaching or assessment sessions. Now I only go with my GPS unit when I do some speed measurements of whatever type of athlete, including cyclists or BMX riders when we do some speed tests. Yeah.
I mean, there's no doubt GPS is a quicker setup than setting up series of speed gates along a track or whatever the environment is. So yeah. I'm sure it's much easier. And
a good GPS is 20 pieces of information per second, more or less. Whereas timing gates are just, if you do a 50-meter acceleration, timing gates, if you have 6 timing gates, it means you're super rich, and it's going to give you 6 individual information, not more. A GPS unit is 20 a second, so there's no, it's not comparable.
Yeah, no, I agree. And what were you looking at with resisted sprints specifically? What's the work you're doing there?
So the work we're doing now is to dig deeper into the programming and the most efficient way to program heavy resistance training, because our work and some of colleagues have shown over the last 10 years that heavy resistance was a very interesting way to improve acceleration kinetics and acceleration outputs. But we've always used some very, classical standard research type of programming, which was 8 to 10 weeks, constant or slightly increasing load, and a very, very repetitive loading scheme. And we've discovered in some research that having a taper period at the end of this kind of overload is very interesting in terms of performance, and that individually different athletes respond differently to heavy sleds and to high resistance training. So we want to now that I think it's clear, it's a good training method if we want to improve early acceleration. This is clear, several groups showing it. But we want to dig deeper into what's the best type of programming, because we've discussed with some elite coaches who use it. They have a very different approach of programming it with their players. We've discussed with team sport players, coaches, who program it differently in season, off season, close to the game or not. And we want to really dig deeper into that. It's going to be difficult to, experimentally test, but that's the research we are doing now.
I don't know whether it's too early to say this or not, but is there any kind of indicators for you as to when, or which types of athletes or what styles of sprint technique, or depending on what their program looks like, is there any kind of indicators for you for who would benefit most from sprint training with a sled?
So basically, everybody can benefit from this type of training. It's like asking who would benefit from SNC and gym type of training. Everybody can. The only thing is who would benefit from what type of load emphasis. And here we have some responses already published. It means that the more, the lower your maximum force and acceleration capability, the more you would benefit from heavy loads as a priority. And it's important to say as a priority, because there is a shortcut where when you say these athletes would benefit from high loads, some people interpret that as do that and only that and do nothing else. No, coaches are not stupid. They know it's a puzzle, and you need some more high loads in this puzzle for these guys, and maybe some more lighter loads for guys with good acceleration but low maximum speed profiling. And so that's exactly the point where we are now. We clearly showed in 3 different studies that the individual response to the same training program was different, which you might expect, of course, but it was related clearly to the initial profile of the players. So it means not everybody benefits from high resistance, but some do. Not everybody benefits from low resistance, but some do. And to me, the magic of good coaching is to identify who needs what. And the magic of good science is to clearly show the standard responses to what type of training load. And the people who are able to mix these two magics will be very good.
And for those who haven't used sleds before, are you typically going off a percentage of body weight to calculate the loading?
Yeah, so I think it's a good way to start. There is one clear thing, is that it should be considered as gym work. You would never give some squats or some press or some deadlift heavy and often to some people who never did. It doesn't make sense. So it's exactly the same with sleds. You should go very progressively. You should, bring them to that type of exercise culture. And then you should program that first as a percent of body weight. It's logical, but the best way to program it is a percent of running velocity decrease. Because if you give to you and me the same percent of our own body weight, we will very likely not run at the same speed, because we have different capabilities. So if you want us to have the very same, stimulus, we should not have the same percent of body mass. Of course, we should not have the same percent of load, the same absolute load. That's obvious. But even the same percent of body mass can be tricky. So you should have the same velocity decrement. This is exactly what happens at the gym. When you have 2 athletes and you want them to work the same thing, you don't give them the same percent of body mass. You give them the same load that will induce the same speed of the bar. This is velocity-based training philosophy.
And while we're kind of comparing, I guess the gym to sprints for an example, in the gym, obviously we can use velocity-based training to set cutoffs for when you're going to, stop the work on a certain lift for an athlete. What are the sort of like non-negotiables, or how would you lay out when you stop an athlete doing sprints, depending on, I don't know, maybe form failure or speed?
Yeah. So that's interesting, because in the gym, when you have this threshold, it's based on a measurement, correct? It's based on a bar speed measurement. So in the field, you should have the same thing, a measurement of speed that tells you when does speed significantly goes below your threshold. So the gym devices that you can use are encoders or accelerometers on the bar. The speed devices on the track could be a radar gun, could be a GPS. This is where GPS are very interesting. Is if you have a GPS unit and you do this kind of session and you have some live feedback, you can know. You can also use some timing gates, like you do some sprints on 20 meters. You track the 15 to 20 meter time, and you see that when this decreases, you know there's something that is close to failure. This is the idea.
And I know there's not always, perfect black and white percentages where you see a certain percentage decrease in speed and then you cut the athlete off. But is there any kind of is there any common approaches to like what percentages you could consider for the cutoffs? I know that's a horribly absolute.
Yeah. So it really depends, because if you want to work on fatigue, then there is no cutoff. You just go until real failure. But if you want to work on quality, my inch here would be to say, look, 10% decrease in top speed. There is clearly something going on. So if you want to maintain good quality work, I think you should stay within the 90% of top speed. This is my experience and observation. When top speed decreases by more than 10%, it really means something is happening.
Yeah, that makes complete sense. Okay, so that's GPS and resisted sprints. The third area you mentioned earlier was running posture. So would you be able to elaborate on what specifically you've been looking at there as well?
Yeah, so as a coach myself, and as an athlete, and as a very regular observer of people running, I think, and this is not an opinion, this is anatomy. The way you run, the way you move your segments, the way you place your trunk, hips, legs during running, influences the tension in your posterior chain, and particularly in the hamstrings. So it means that by modifying your posture, you can modify the tension in the hamstrings. This is clear. There's some simulation studies, and it's anatomy. When you move your limbs, you stretch the muscles. One way or the other. It means you can reduce the tension in the hamstrings by running in a certain way, but you can also increase the tension in the hamstrings by running in a certain way. And this is, all things equal, to my opinion, related to the risk of injuries, because if you do the same movement, that's a very high speed movement, with a different length and a different tension in the hamstrings, mechanically speaking, you have a different risk of strain injury, because injury is a mismatch between the capacity of the muscle to face the mechanical strain and the strain that is, into the muscle. So if you want to prevent injuries, you have two ways, two buttons to push. One is to try and reduce the strain. One is to try and improve capacity. But if you over-focus on improving capacity by, strengthening the muscle at long lengths and so on, but you don't focus on reducing the strain, maybe the balance will always be negative. And so research in the last 30 years have been addressing improving capacity, but reducing strain has been, to my opinion, almost omitted. And I think this is a key in, at least it's an unexplored. So we should give a chance to this logical approach.
Yeah. And I guess one of the things I wanted to talk to you about as well today was when you're assessing or profiling a sprinter or runner, how granular do you go? Because obviously we can look at running speeds, we can scale things back and look at force outputs, jump in and look at metrics like RSI and ESI, and then you can even go down to like individual joint torques. How granular do you go yourself?
Yeah. So this is exactly what we do. We profile the kinetics by measuring or estimating the forces that are produced. I mean, the external force output. And then we go to the kinematics, that is the segment movements. And of course, almost nobody can assess correctly the 3D kinematics of fast running people. So we have some field approaches that are simple enough to provide good information and complex enough to, go deep into the position. So we measure in the sagittal plane of running the main 2D kinematics with high-speed cameras, and we focus on trunk angle, hip angle, thigh positions, and foot positions. And there's three main things that influence the hamstring strain. Trunk angle, the more forward-oriented your trunk, the higher the tension in the hamstrings, all things equal. Pelvic tilt, the more the pelvis is tilted forward, the higher the tension. And the movement of the thighs, because the position of the thigh at the moment of touchdown is related to the tension in the hamstring. So we really focus on that. So I would say it's a mix between super complex, very difficult, nobody does it, 3D motion capture at the lab, and very, over simple, just looking at someone and say, okay, he has a kick butt and it doesn't run well. So we are trying to find an in between that is, valid and doable.
If that's the kinematics, how far down the rabbit hole do you go for looking at kinetics as well?
So kinetics, it's exactly the same story. If you want to really have the kinetics, you need force plates onto the track. And this, you can only have access to that in a few labs in the world and for a few steps only. So we have a method to estimate the force output in the vertical and forward direction that's been validated against force plates, and that really only needs the speed data. So again, if I have a GPS or a good speed measurement device and I know the speed data during the acceleration, I can recalculate the main kinetics, the force output. But I cannot have the impulse for every step, and I cannot have other, I would say, a bit more complex, like braking impulse versus pushing impulse. This I cannot have. So it's always the same story. I can have some pretty good amount of information, but I can have it compared to, laboratory setting that I can have much more information, but there's almost no chance I can take my athletes there. I do myself at my lab. I'm very lucky because I have all of that. So for some elite athletes, we do such measurements. But to be honest, we only do it a few times a season because they are not available. So this is why I use much more often my field simplified methods than my laboratory, rocket science devices.
Yeah. And, academically speaking, when we're looking at, say, muscle contributions and kinetics and kinematics of sprinting, what, tools or academic topics give us, assumptions versus give us trustworthy insights? And I guess really what I want to know is there any misconceptions that we rely upon?
No, everything is super limited. There is no gold standard because right now we cannot measure directly the force in a muscle during movement. So we only use indirect approaches. One is surface EMG, but it has clear limitations. One is ultrasound, but it has clear limitations. Typically, we measure a very, very tiny part of the muscle at rest, and we try to extrapolate that to the behavior of the muscle during movement. That is, crazy extrapolation. Same for surface EMG, and same for modeling, where you film the external, shape of the body, and you try to infer the internal movement of the muscles. It is very, very extrapolating. So, and this is why sometimes in the literature or in social media, this battle against between people that your method is flawed. No, it's yours. No, it's yours. EMG is better than this, or ultrasound is better than that. I think it's overall very stupid because all these methods are, very, very biased methods. So it's very indirect right now.
Yeah.
And I use almost all of them in my own studies. Okay, so I totally, acknowledge and embrace these kind of limitations. But my philosophy is to say, what's best, doing nothing and stay there, or trying to push some new things using very limited approaches. But knowing the limitations, some of these approaches bring some informations anyway.
Yeah, and I mean, limitations or no limitations, you've got to use something to push the conversation forwards.
You but you just have to be very aware of the limitations, and also very aware of the limitations of other people's approaches.
Yeah. I guess from a practical standpoint, we've spoken about posture, GPS, sprints, programming. We've spoken about tons of different things. How do you kind of, an athlete's in front of you? How do you organize your thoughts? How do you, get this stuff down on paper, or how do you form a way of communicating this information and I guess collecting it as a snapshot of that athlete in that moment as you see them? Because there's lots of different variables that we're talking about here.
Yeah, that was very interesting. So I tend to first not measure anything. I tend just to let the athlete move, and I watch very, very carefully the warm up, the performance, some sprints. Then I try to measure the running speed to calculate everything, and then to film in slow motion the early acceleration and late acceleration. And I usually end up with a picture that is something like 6 to 10 main variables. And then we can discuss things, but I always use the variables as the very last piece of argument to explain to an athlete their margin of improvement, their limitations, because I start with the way they move, and I start with discussing with them. So there is no data, there is just discussion. What do you feel when you do that? How can you explain the way you do that? To have their own perception of what they do, and then I bring the data to further discuss, because the data will help me orient the type of training, and the data will help me check if my work, my intervention has been helpful and in changing what we wanted to change.
It's really refreshing to hear that someone with your especially, I guess, your technical and academic ability using data and tools to create data. It's really refreshing to hear that you, I guess, and correct me if I'm wrong, go big to small, and you look at the athlete with your eyes and look at them qualitatively and from a coaching eye first before you go, sports science and metrics.
Yeah, because I don't want to work on data. I want to work on movement. So this is very, very important.
Yeah. And I've heard you speak previously and discuss the evolution of sort of technology and hardware. And you've mentioned labs earlier today for ways that have enabled us to sort of understand force velocity outputs of running and speeds. We've touched upon GPS. Is there any other sort of, I'm just thinking with the sort of practical coach in mind, is there any other modest options that you commonly use or would sort of turn people to when they don't have, force plates and other more expensive tools?
So to be honest, today you can work, I think, very, very efficiently with a budget of $2,000 per season. $1,000 per season will be with one GPS unit. I mean, if you work with individual athletes, of course. And the other $1,000 will be on a very good, iPad camera. I say iPad because it's a very practical 240 frames per second devices. And with this, you can already do a lot of technical stuff, a lot of, force velocity profiling. You can basically do almost everything we've published in the last 10, 15 years and have it in your toolbox. Plus, we've published some free Excel spreadsheets that can help you process everything for free. So you cannot do a lot if you don't have this budget. But I would say it's a pretty minimal budget. If you think about it, plus the iPad, when you have it for 10 years if you take care of it and so it's very cool, because when I started my master's degree, it was in 2000, so more than 20 years ago. With $2,000, you couldn't do all that, for sure. So you had only just timing systems or manual timing, but manual timing of somebody doesn't tell you a lot. And so that's definitely a cool time to assess people.
And you've discussed kind of lots of the different, the research and academic areas you're working within. How do you kind of spend your time non-academically coaching? And, are you consulting? Are you moving around much within different teams and athletic groups?
Yeah, that's exactly it. So typically I have about one day per week or one day every 2 weeks where I am either with athletes individually, coaching, consulting, or coaches. Because I like to teach coaches how to, then do things themselves instead of myself going to coach and so on. So I would say that's about 10% of my time, 15% of my time.
Very cool. JB, just before we close down this conversation, is there any closing thoughts that you want to share that we haven't been able to squeeze into today's conversation?
No, I think if the audience is mostly coaches or people, performance practitioners, I guess the most important point is that they don't take every academic piece of research published as a golden rule, and they keep their own, eyes to assess the quality of research, because the key thing is that not everything that's published is gold. And so you have to keep this as an additional piece of information, not as the rule, definitely.
I think sometimes it's easy to kind of almost read research papers and collect convenient facts, stats or references that back up your own biases. And I've probably done that myself on a number of occasions, but it's always tempting.
Yeah. I told that once. It's a very funny anecdote to the manager of the French rugby team, because after a PhD defense, he came to me and said, you've discussed the quality of research, and I didn't know that there were some published poor quality studies and good quality studies. I thought everything that was published was great. And I told him it's exactly like a rugby game. Not all victories were good rugby. And so he said, okay, I understand what you mean.
And where's the best place for listeners to find you? I know you're active on social media, so what are your handles? And have you got anything else that people should look out for in your pipeline of work?
Yeah, so for sure, what we publish and what I think important to notice from other people is through Twitter at JB_Morin, and I have a personal website, jbmorin.net, where I put all the things we produce, the spreadsheets, the conferences, the podcasts, and so on. So anytime you want to reconnect to my work or contact me, you go to my website.
Cool, perfect. Well, JB, I've really enjoyed the conversation today, and I thank you greatly for coming on. Appreciate your time.
Me too, thanks. Thanks a lot.